Hi everyone, and welcome to PyData Manchester for our November event. Today we're joined by Rebecca Davey, who's going to be talking about Docker and how it can help us all with data science. And I don't know about you, but after this year, I will take all the help I can get. So if you're interested in getting in contact with us and interacting, and please do, you can find us on at PyDataMCR on Twitter, or alternatively, you can join the Slack at tinyurl.com/PyDataUK-Slack. And also obviously in the YouTube comments as well. We'll be in there around and about. So who organizes PyData Manchester? Well, behind the scenes today we've got Joe, who's handling the streaming. Got me, who's doing the talking and hosting. Jennifer and Sean will be in the YouTube comments, getting involved with chatting. And if there's any issues, then you can get in contact with us via Twitter, or just mention something in the chat, and we'll do our best to help out. PyData Manchester is part of the PyData community, and it's a professional meetup environment, and it should be treated as such. So as part of that, we've got a code of conduct that we expect everyone to abide by. And the core message is that PyData is dedicated to providing a harassment-free experience for everyone. So make sure we can all abide by that. If you see anything or hear anything that you're not comfortable with, message one of the organizers, and we'll do our best to help out. Friends of PyData Manchester, we're normally in real times, we're joined by Open Data Manchester, Python Northwest, Herplus Data, and quite a few of the Manchester data groups. At the moment, these are the three that are still running events throughout lockdown. So check them out. I know Open Data Manchester are still running their pick and mix for learning new data skills, and I believe Herplus Data have an event next week, I think. But I know all three of them are doing stuff, so definitely check them out. Our podcasts have slowed down recently, but our four most recent ones were all fantastic conversations. So I urge you to check them out and give them a listen if you're interested in that kind of thing. If you've got any announcements, if you're looking for a job, if you've got a job you're looking to hire, a data science, data analyst, any kind of data person for your business, then pop an announcement in Slack channel in jobs. If you're looking for a job, pop into the jobs channel and try and see if there's anything in there for you as well. And if you're interested in organising a meetup and you want us to give you a shout out, then please do. Just drop a message into Slack or get in contact with one of the organisers, and we'll do our best to help. So yeah, if you want to get involved, like I say, whether it be speakers, as a podcast guest, as a sponsor, or as part of the Code of Conduct response team, give us a shout. And thank you as well to our sponsors, Horsefly Analytics and Cathcart Associates, without whom this wouldn't be possible, and NumFocus for helping us with the entire PyData stack, both PyData global, but also just PyData code too. Yeah, so without further ado, I'll pass you over to Rebecca Davey from Netsia, who's going to tell us all about Docker for data science and how it can help.
Yeah, hi. I'll just share my screen and get started with me. Okay, great. So yeah, thanks very much for coming and joining us this evening. My name is Rebecca. I'm the lead data scientist at Netsia, and I'm going to talk about Docker and the containerization of software and how it can benefit your data science projects. Before I go on, so Docker has one of the cutest logos, and I've lent on this whale theme really heavily, so I'm sorry if that gets too much. Just a heads up, there's a lot of whales in this talk. So a little bit about Netisia. So we're a Manchester-based company, and what we do is use machine learning to build products for the detection and mitigation of like a whole range of online bot threats. This could be credential stuffing or card cracking, which is where people are kind of taking big lists of compromised credentials and sort of trying them in a burst, so quite volumetric attacks. We also look at slower stuff, maybe things like web scraping, or one-off things around maybe releases of tickets and fancy trainers, stuff like that. Quite a big range of problems. And we sit as a layer between the user and the website, making real-time predictions around the intent of the requests that are coming through. And then in addition to that, there's a whole load of more latent analysis that goes on. And as a data science team, so it's a small and young company, really. So we sit quite close to the productionization and the deployment of these models. And Docker's really proved invaluable for helping us to manage these models and the different services that we run. And so that's why I wanted to share what I've picked up with you today. So starting just with a basic overview of Docker, it's a software, and it's software that lets you run and manage containers. So what's a container? Container is like a silo of running software. I'm going to use the word silo a lot, I apologize. And I'm going to come back to the definition of a container a bit more closely in a little bit. The gist of it is that it's a running environment that's kind of isolated from your machine, the host that it's running on. And the notion of containers isn't unique to Docker by any means. They're a very well-known implementation of it, but it's not synonymous. So there's other ways of making these containers. And probably one of the best ways to think or to describe containers is to think about what they're not, which is they're not virtual machines. And the distinction between them is quite useful to remember. So we've got this diagram on the right here, which is showing us on the right-hand side, if we think about virtual machines, what we're looking at are these applications where they are running on an operating system in a way that is virtualized inside your computer, including the operating system itself is bundled in there. Whereas if we're using Docker and containers, we can have all of these little containerized applications, but they're still ultimately running on the OS of your machine, the host, and Docker is sitting in between managing those interactions. One of the benefits of this distinction is that you can see we don't really have to bundle the operating system in here, which means compared to virtual machine kind of applications, containers are quite lightweight, which is nice. So, from that we can see is that what we're trying to achieve, we're trying to encapsulate and kind of seal off that functionality and that infrastructure, but why do that? What's the point? And specifically, why in data science, why do we want to do that? And I think you can boil it down to several different reasons. One of these, reproducibility. It's obviously very important when we're running scientific experiments that we can have this. And we want to ensure that what we're building is trustworthy and fair. We want people to be able to recreate what we do reliably. Portability is a really big one. So as well as meaning that we can share the software easily with other collaborators or with platforms, it also means that when we get to the point of wanting to deploy software onto a different environment, it's quite straightforward. Collaboration, so things are always nicer when we work together, and it doesn't matter now if you've got a mix of tools and even operating systems on your team. It really facilitates that kind of collaboration, or even onto other teams. Maybe you're working with a team of developers who don't have a full data science setup. That's not so much of a problem anymore. And finally, I guess just machine hygiene. So why keep around lots of software that you don't especially want to use or maintain? Why sully your beautiful, clean workspace with this stuff? And so in data science, I think you can further kind of split this into two categories where it's really beneficial. We've got Docker for development, building and developing the models and pipelines we use. And then you've got Docker for deployment. And so I'm hoping today I'm going to go through a few different demos, different scenarios across these and sort of show how Docker can help us in these cases. But firstly, I'm going to talk just about a really straightforward scenario where we've got a single container running a very simple batch process and how we might want to manage this. Before I get there though, so as the diagram earlier suggested, if you want to be running Docker, you need to have Docker installed and running on your computer. You need to be running the Docker engine. If you're a Windows or a Mac user, by far the easiest way to do this is with the Docker for desktop client, which you can download from online. Things get a bit more complicated for Linux users. Once you've installed the desktop client and have used that to start Docker running, if from that point you only ever want to use the command line interface, then that's cool. And in fact, that's what I'm going to be doing in this talk, is showing it all through the command line. You can do most things there in the nice interface, but this way you can do both. And that's a good reminder that I should probably start Docker running for the talk. If it's not already. Okay, it's already running, that's cool. Okay, so yeah, so let's run through a kind of very basic scenario and get a feel for what these things are. But first, some information on images and containers. So these are two words that I'm going to use a huge amount. And if you haven't used Docker much before, these might feel quite similar and easily confusable. So I want to try and build an intuitive feel for what they are and how they might be different. I'm going to use an analogy of thinking about an old-fashioned movie reel and a cinema screening. So if you've got a movie reel, it's a very fixed thing. It contains everything. It contains all the information you need. You can put some stickers on it with the name. You can pass it around to your friends. And as long as they've got the equipment to run it, so like a projector, they can pop it in and they'll all see exactly the same thing. And then once you've put that in a projector and you're running it and stuff's coming out, you've got a screening of that movie. And that's kind of maybe a bad analogy, but to images and containers, where an image is a kind of a ready-to-go unit of your software. You can put tags on it, names, versions, but it's still a static thing. And once you run that, you've created a container. It's like a live instantiation of that image, which is either running or stopped. You could be running multiple containers of the same image at the same time. So that's, I'm going to be using these words a lot, and it's kind of important to understand the difference between those. So it might feel kind of daunting. You want to make an image for your software. Do you have to go and include the source code for everything? Say you're using a database connection, do you have to go and find all of the MySQL code and include it in your image? No, that's the good news. Images are cumulative, and you only have to worry about adding in the stuff that you're adding, your code or your app. And this cumulativeness is created with image layers. So starting from a base image, which in this diagram is Ubuntu 15.04, we're going to add layers on top of that to ultimately create the image that will run as our application. We don't have to worry about programming a whole operating system or any kind of stuff underneath it. We're only really adding what we care about. So talking about these images, if you want to get a base image, what do you do? Where do you get an image from? So Docker Hub is kind of a parallel almost for GitHub. It's a remote repository of Docker images that you can pull from. So let's just go check that out quickly. If we go to explore, we'll see some pre-made and popular Docker images that you can pull, like Docker pull Couchbase, and you'll have a copy of that image locally. So let's see what we've got. There should be Python on here somewhere. We're going to use that one today. Things like Node, Nginx, Ubuntu. So these are pre-made images that we can pull and then use as base images for applications that we're making. And if you're thinking, like, how do I know which base image I should use, which is a good question. I think there's probably a couple of guides you could look at. So one thing would be, if you know that you're going to be able to deploy your code in the container that you're currently building, I would just try and choose the thing which covers as much of the functionality you want as possible. So there's, you have to expend as little effort as possible adding your stuff on top. If that's not the case, then I would aim to be recreating the environment I am going to deploy into as accurately as possible with those. Something I've tried to do is to include in here these orange boxes, which are Docker commands that you're most likely to be using a lot, kind of the highlights, I suppose. And so this one here, Docker images, is something you'll run, and it will show you all of the images that you have in your kind of local image repository. So let's do this. Hopefully this is big enough. So images. We can see a load of the ones which I have already downloaded. So Python latest, Ubuntu latest, we've got Node in here as well. You'll see they've got tags against them. So much like packages or branches in Git, we can apply tags and versions to images. So we could say Docker pull Ubuntu 16.04 or whatever it was. If we don't specify that, it will default though to latest. So, oops, Okay, so how do we make an image? These are the base ones, but we want to make one from our code. How do we do that? The answer to that is the Dockerfile, which maybe people have heard of. What the Dockerfile is doing is where we specify how we're going to add those layers onto the base image to build up our final image. You can see, so there's this example on the right. They always start with from, and then the base image that you want to build from. And what you're providing are a sequence of instructions for how we should go about building the environment for your container and what software we want to run in that container. So if we walk through this one, we're saying, okay, building on the Python 2.7 base image, we're going to copy the files, which are kind of at the same level as the Docker file in our host machine, and we're going to copy that into the root of the Docker image. We're going to run pip install, which we can do because that's included in our Python base image. We don't have to worry about installing pip ourselves. And then we're going to say command python app.py. And what we're doing here is we're saying, this is what we want you to execute to actually be running the software in that container. You might also see entry point here instead of command. They're kind of similar, but there's some subtle differences. If anyone's interested, you can cover those later. If you'd like, let me know. So this is going to bring us on to the first of the little demos. So I'm going to switch over to my editor where we'll see this Docker file again in single container demo. Here we go. We can see the requirements.txt file we're pulling is this one here where we've set NumPy. And we've got an app which is doing a kind of dummy task here. I've minimized these functions, but what we're doing is we're setting up some logging and taking a environment variable, and we're saying, okay, we're going to get some data, we're going to detect the anomalies in that data, and then we're going to write out those predictions. Maybe this is a job that runs every hour or every 3 hours. These functions aren't doing anything. I think they're mostly just making, like random data. And so with a batch job like this, in terms of how you've got this running, it's not necessarily the case that Docker is going to help you a huge amount with like the deployment of that. It might be a notebook or it might be a cron job that's running. But in this example, a benefit we have from Docker is, say we know that the environment that's running this is old and it's limited. Maybe it's not on Python 3 and for whatever reason it's not going to move there. We don't have to worry about getting a local environment with Python 2 on it. We can just pull the Python 2 base image and work with that, which is really nice. So we can see, so this is app.py that's going to run. When we tell the Docker file to run this, it's going to run these functions, write out the predictions. Maybe it would be to S3 or something, although here it's just going to log them. Okay. So turning this Docker file into an image brings us onto the next command that we want to know about, which is docker build. And it's how we turn the Docker file and the context, which is the kind of, the surrounding source code and files, into an image. This is the command that we would run. So we've got docker build, some options, and then the path. The options, there's lots of these. The Docker docs online go through them all very thoroughly and nicely. One that I've called out specifically in the bottom here, which I think is quite useful, or at least you see it quite a lot, is -t here, which is saying when you build this image, apply this name and optionally this tag to it. But there's others you could put in here as well to do various things. And then the path URL. So this is going to be pointing to the location that contains the Docker file that you want to run. So in this case, we're expecting that we'd be running this in a directory that contains a Docker file that is referencing, the files around it to do things like copy and run pip install. But this could also be a URL. So this command here, docker build, blah, 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 https GitHub, that would achieve exactly the same thing because it's saying go to GitHub on the main branch, look in this subdirectory and use this as the context for building that image. So these things would work equally well. Oh, by the way, so the code for these is it's on GitHub, so you can pull these and run these if you'd like to. Okay, so let's try building the Docker file that we've got in the demo. Where are we? Let's go single container. So we're going to say Docker, sorry, it's going to spread across the lines awkwardly because it's big. Single container demo. And we'll see what it's saying here. So, okay, it's using the Python 2.7 base image, because I already had that in my images, it doesn't need to go, where is it? Oh no, it doesn't have that, but it will pull that in a minute. It's running through the commands we gave it basically. So it's copying the code across, it's running pip install, it's warning us that Python 2.7 is old and out of date, which is fair. And it's getting to the bottom. And it's not actually running any code at this point, but it's building up those layers of what we've told it to give us a final image. And if we run Docker images again, we can see that because we've now got single container demo latest up here as an image created 22 seconds ago. Okay, good. So it's, I mean, and if we kind of sanity check that a bit, it should be bigger than the Python 2.7 image, which it is. That makes sense. That's good. So we have an image, and the final step in the process, that big diagram, is turning that into a container, which is where Docker run comes in. So similar to Docker build, we're going to be saying, Docker run, and then the image ID. So that could be, actually, if we pop back, we've got the name here. The images, when they get created, also get an ID. You could pass through either this big ID or the name, again, in which case, if you don't give a version, it will default to latest. So we could run Docker run, then our image ID. You don't need to pass any extra arguments or instructions through at that point if you've got that command or entry point back in your Docker file, because it's going to be running that. If you don't provide that, then it will fall back to if there was one of these in your base file. So an example of this is that the Python base image, its kind of command statement at the bottom is to run the Python interpreter, like the Python shell. And so say we in our Docker file hadn't put in this, but we tried to do Docker run of this composed Docker file, we'd end up just opening the Python terminal because of that, which is kind of cool. And yeah, there's lots of, like with build, there's lots of options you can kind of stick in here. Lots of very useful ones. Again, they're in the docs, and there's going to be a few, and I'll kind of call them out as they come up through the different demos. So in fact, one that I've mentioned down here is --rm. Which in this case is going to say, once we've run this container and it's exited, we don't need to keep a copy of that container around anymore. We can kind of tidy up after ourselves. Docker's really big on keeping copies of everything it's done. It's big on that. Okay, so let's run this and see that it starts a container from the image that we've just built. So we're going to say Docker -rm simple container demo. Okay. So, I mean, it ran the code. These are our fake anomalies. And we can do Docker PS, which shows us containers that are running, except this isn't running anymore, which kind of agrees with the code that we've got, right? Because it got to the end of this file, and it didn't have anything else to run, so it shut itself down. We could normally say Docker PS -a to also see the exited containers, but because we put that cleanup -rm, there's nothing in there either. So it did run, but it just got to the end and it's closed and gone away again. So that's great, but that's not very interesting for our demo. So what I'm going to do is I'm going to add at the bottom here, I'm going to say while true, just continue, just stick doing nothing forever. And then we're going to rebuild that and take a look. So it's going to rebuild. Yep. And let's run that again. And let's pass through an environment variable this time as well, so we can look at another of these options. So I'm going to say I don't want to use the default standard deviation threshold. I'm going to say that this is now 3. The way we do that is using this -e option here. So let's run this. Okay, so it's run again, but now it hasn't exited. And let's open a new terminal. And we can see that this is now a container that's running. It's running the single container demo image. It's running Python app.py. It's given it a kind of generated name. Yeah, okay, but it's not doing much. We know it's not doing much. It's just in that while true loop. But at least now it's it's a running container. Which brings me on to the final command I'm going to talk about, which is docker exec. So where docker run was about taking an image and turning that into a running container, docker exec is about taking a container that's already running and then executing a command against that already running container. So we could do an example of that. We could say docker exec, let's take this container, and we want to say just echo, hey, PyData Manchester, Hey, PyData Manchester, and it's not a particularly complicated instruction, but it's taken that and it's executed against that that container. Another way that you'll commonly see Docker exec used is to open a bash shell inside a running container. And to do that, we're going to use this extra option here, -it, which is actually two options smushed together. So it's -i and -t. And what it's doing is saying that it's going to wait now for input from the terminal. It's going to be an interactive kind of command, and it's going to surface the shell that we create back into our terminal, essentially. So let's have a go at running that. We can say exec -it bash. Okay, and now we are in the root of this container. So again, we could just go like echo hey, and if I'm going to make yet another tab. We can see Docker PS. We've still got this running, and there's another. I think one of the hosts might have unmuted themselves. By the way, I can hear some little noises.
Sorry, that's me, Rebecca. Someone's asked, when you're running multiple commands, is it okay if you can just clear the output so we can see your commands at the top of the terminal?
Yes, I'll do that. Okay.
Thank you.
Yeah. So another command that I'm just going to mention is we can say docker container top, and it will show us the processes that are currently running in that container. And we can see now there's two. There's our original Python one, and there's this bash one. Let's go get out of this with Control D. We'll run this again. Now it's just our Python app. And we could go ahead and stop this container. So if we can go back to stop. We could also just do Control C and force it to stop as well. Okay. So those are the commands that you're going to be using most commonly, I'd say. And hopefully that's kind of given you an idea of how the kind of the basics of Docker and how it works, and the difference between the images and the containers and so on. So next up, another bit on Docker for development. So in the example we just saw, that entire code was in a little bubble of its own. It didn't interact with any other services. It didn't need anything, which isn't really that realistic. Most likely you'll have some code that needs to interact with something else, maybe an AWS account or a database. So let's say you have something like this, where you've got an app called Stream Processor that needs to pull some information from S3 and then send something to Kafka. But we want to work on Stream Processor. Maybe we want to work on some aspect of it. We want to test it. We think there's a bug in there, whatever. So Jordi here is telling us exactly what we need to do. We don't want to end up testing this against our production AWS account or the Kafka server. But how do we test the interactions with these different components? And this is a way that Docker can help us, because we can use Docker containers to mock up these services. So an example of how we do that for this scenario would be this, right? So we could set up 3 different containers. We could set up one which is local stack. So local stack is software for kind of mocking up an AWS account locally. And say Stream Processor is using Boto3 to access AWS resources. If we pass Boto3 this container's IP instead of our production AWS endpoint, as far as Stream Processor is concerned, it's interacting with AWS. It doesn't mind that it's another local container. Similarly, over here, say we set up another container that's running as a Kafka server, and this creates for us an endpoint that we can use when we want to contact a Kafka broker. As far as Stream Processor is concerned, that's just the same as our production Kafka server. And we can run all of these things, but this is quite a lot to manage. There's a lot of things to keep track of. We're going to need to be passing in different environment variables and maybe port settings to these different containers. It's a bit of a faff. Unfortunately, Docker Compose is the thing that comes to our rescue here. So Docker Compose is functionality within Docker that lets you describe how you want to build and run multiple containers or services that are going to interact with one another without having to, imagine how many tabs I'd have open by the end of doing all of that. It does it all in one hit. And the way it works is using this Docker compose file, the markup file you can see on the right here. So in this example, we're saying we want to create two containers. One of them is going to be running MySQL, just the standard MySQL image, from Docker Hub. And we're going to set some environment variables, some port stuff that normally we pass in with Docker run. All of those options and commands now get covered into this one file. And we also want to create a second container called MyApp, which is going to depend on that database service. We're going to send in some more environment variables. And this time, it's not an image with a name that we're going to pull. We need to build it from our local file system. And so this way, we can kind of orchestrate these different services and containers. The two commands here, which are most likely to be useful, are docker compose build, which is going to look through these services and say, okay, what images do I need to pull in or build from scratch if we want to run all of these things? If say your Docker file here changed since the last time you built it, it would rebuild that as well. And then the other thing is docker compose up or down, which is how you're going to stop and start these things running. So docker compose up is going to start all of these services running. Okay. So the demo that I'm going to go through is looking at a scenario with Kafka. For people that haven't worked with Kafka or aren't familiar, it's a messaging platform. So it's a sort of publisher-subscriber system. So in this sense, you have a Kafka topic or a channel, and publishers can send messages to that channel, and they don't have to worry about who's going to be consuming those messages. And subscribers can just say, I'm interested in whatever comes to this channel, this topic, and I don't care who sent it. And so that's the pub subsystem, is where you've decoupled those bits of communication. Kafka manages that by having a Kafka server or Kafka broker, which is kind of sitting in the middle, handling that communication from both sides and passing the information around, and storing the messages in topics or topic partitions, because they get split into different partitions. It's used often for streaming data, or input into streaming models, for a few reasons, mostly due to good, I think, design decisions on the part of Kafka. It's very performant. It's also very reliable. So once a message has been published to a topic, if there's a consumer somewhere waiting for it, it's pretty much going to get through no matter what happens. It's very it has lots of ways of replicating the data and making sure that there's a constantly available service. So let's say for our demo, we have been tasked with writing an algorithm that will predict if a tweet from a stream is in English or not. And we want to work on this, but we don't want to have to, maybe we don't want to have to handle or store the production credentials of the service we're working with in this development environment, or we have just been told that we can't access that stream, we're not allowed, or just, for cleanliness, for good practices, we want to be able to mock up that input without having to actually interact with that production resource. And so that's what we're going to look at in this demo, which is the multi-container demo. So this is our Docker compose file. We're building a few different services here, so let's go through them. The first one is going to be Kafka. We're going to call it Kafka, and it's pulling the Kafka image that was hosted by Spotify. We're going to set some variables here. We're going to say, okay, this is the port that you need to talk on. And so now we're going to have a container which is running as a little Kafka server. In real life, these would be running on a cluster of machines with lots of replication and whatnot. This is just a single node example. In our use case, we need something that's going to simulate that data coming in. And so we're going to build a second container, which is called fake stream. And this is the data directory up here. It depends on Kafka. We're going to pass in some variables about that Kafka stream. But let's go have a look at what that's doing. It's not doing anything super fancy. It's the same kind of Docker file. So we've got some requirements, we're installing them, and then we're running Python producer. we're taking some sample data, some sample tweets. So it's similar to our production data, but we don't have to worry about that stream. Maybe we can anonymize it. Maybe it can even be dummy data. We're making a connection to Kafka, and we're going to send those out as messages to that server, just every couple of seconds. So it's it's obviously not the same as the production resource, but we can control quite a few aspects of it so that it's similar enough for testing our prediction function. Just looking at Docker Compose. And so the third container we're going to build up is predictor, which is our model, which is predicting based on this incoming stream. Again, it's going to build from the context that we've got here within this repo./predictor. It depends on Kafka and the fig stream. We'll have a look at that quickly as well. Again, similar Dockerfile. The difference this time, we're running wget and pulling in a big corpus of the 10,000 most commonly used English words, or which gives you an idea of how sophisticated maybe this prediction thing is. It's not very smart. It's we've got functions in here which are going to do some pre-processing. We're going to make a prediction on the language in a kind of fairly dumb way. But the actual thing that's getting run here, so Python predict.py is going to come down. Oh, sorry, I've written the wrong thing. It's going to read in these words. It's going to set up a Kafka consumer, and the way that it's going to consume those messages, it's just saying, as long as there's a message available for the consumer, it's going to run this code. It's going to process it and make a prediction based on it. And again, this is going to log these out to the output. So yeah, these are the three containers that we're going to build. And you can hopefully see how this is going to create a kind of replica of the environment that this predictor component will ultimately be exposed to. So let's go ahead and run Docker Compose for that. We don't have to build the images individually because Docker Compose is going to take care of that for us. So if we see what it's doing, yep. So we've already got Spotify Kafka locally. We don't need to pull that in. It's doing quite a lot. It's building the fake stream image. It's building the predictor image down here. And if we have a look then in our Docker images, we'll see that it's created images for those two kind of sub services there. Spotify Kafka is already down here. Okay, and then the next one was Docker Compose up. This is going to be quite noisy because I set the logging level to info, so we'll just see what happens here. So it's creating containers for these images it's just built. Okay, this is all noise because it's Kafka trying to establish connections. We can see on the left here, you've got the name of the different container or service that's creating these log lines. Again, this is all stuff that would normally be hidden, but it's just because I've set the logging level quite low for this demo. But we get to the point where a connection has been established and this data is coming through. So we're going to sit at the bottom here and we'll see stuff coming through. And then as far as our predictor is concerned, this is the same as if it was running in production. It's seeing similar data to what it's going to see. It's maybe seeing it at the same pace. And then we can go away and work on predictor one to our heart's content without ever having to touch our production Kafka server. Okay. I think I'm just going to Control C to stop that. It's not very nice, but there we go. Okay. So that's an example of running Kafka. If you're feeling brave, you could even try running Spark in Docker. There's if it's software that you can pull and run, you can run it in Docker. So for Spark, you'd be wanting to set up different containers to be the master and worker nodes for Spark. You could try and build your own images for these if you wanted to write a Docker file that would set all of that up, or you could use pre-made ones from Docker Hub. And once you've got those running and communicating in the right way, running a Spark job in a Docker container would be just a case of getting onto that master node and Spark submitting your script in a familiar way. And yeah, maybe you probably couldn't do anything super high powered because ultimately this is still just your computer, but maybe you wanted to test something out. Maybe you wanted to try and familiarize yourself with the Spark internals without having to install anything on your machine. Okay. The third section I'm going to talk about is deployment. So I'm mostly going to talk about deploying to cloud services with Docker, but first I'm going to do one last little local demo, which shows how we can run a lightweight web server in a Docker container to expose a model as like a prediction input. And for that, I'm going to use Flask. So I imagine some people have used Flask before. It's a very lightweight web server and app framework for Python. And we can see here the Docker file that I've got for this demo. Again, it looks very similar. The difference here is that we've added expose 5000. So port 5000 is the default port for Flask to expose for making web requests to that server. And documenting it here is good. It's not strictly necessary to run it, but it's a good practice to document what the sort of the ports that are going to be involved with that container. So with Flask, you can, in your regular code, you could set it so that all of the post requests or all of the requests to a particular path get routed to a function in your code. So that's how we're going to join up the requests with our Python code. And in this example, we're going to say that all of the post requests to a particular path are going to be against the function that will make a prediction from our model. So we'd expect that those post requests have some data being carried with them, and that will be the input to our model. And the premise for this demo is that we have an animal classification problem, and we want to say very quickly, for some reason, what an animal is based on some vague notions about what it might be. So again, let's look through this code. Up here, Dockerfile, as we just seen, we're running python server.py. So let's have a look at that. We're setting up our app up here. Again, this is not a sophisticated machine learning model. None of the ones in these demos are there, just for example, but something. If you wanted to have this loading a machine learning model and making predictions with it, you can imagine how it wouldn't be too dissimilar. Maybe you have a file here, which is a stored version of your model, and you load that in instead of creating this animal predictor class. It's a very dumb model. It just looks at how many legs you're dealing with and tells you what it thinks the animal should be. And down here, this is the function that we're going to ultimately be calling, which is going to take that input and run it through the model, and then return that as a response to the request. And when we run python server.py, we're going to start this app running. So again, this is a slightly different way of using Docker, of using the app. But let's go through that and see what happens. Let's put that down. So again, we're going to want to build this. I'm going to say basic Flask demo. It's going to build that image for us. Let's go see it, some new images. Okay, it's up top here. Oh, we've got a none here, which I'll mention briefly because it's quite interesting. So back in the first demo, if you remember, we built it once and then we changed the Docker file and we built it again. And both times we specified that we wanted the image that got created to be saved as a single container demo latest. So this is the problem where the first image that we built no longer has a reference to it. And so it will appear here as none, which is a dangling image. And you can run sort of cleanup operations like Docker prune to get rid of these. But that's, if you see that none in your Docker images, it's because you've kind of overwritten it and put the label on something else. But now, so we've got the basic Flask demo up here. That's great. And we're going to want to run this, and we're going to introduce a new option to do this, because now there's the added complication that we need, or we want to interact with this from outside of Docker, which is where we're going to have to do a port mapping. So I'll show that. So we're saying docker run And we're going to say -p 5,000 to 5,000. And what we're saying here is that we're establishing a mapping between the 5,000 port of the Docker container and of the host machine, so that we can basically make requests against that container on that port outside of the container. And, oh, sorry, I said I'd do this at the top, didn't I? Sorry about that. So we're going to do docker run -p 5,000 basic Flask demo. Okay, cool. Serving Flask app server. Warning: this is a development server. Yeah, you're not supposed to use Flask for anything that requires great reliability due to the way it's built. There are other alternatives for that, as it says. Okay, and now it's so it's running this server at this address. So let's make another. Oops, let's make another tab. Let's look, see it running. Yep. So basic Flask demo is running, and we're running this, so we're not in a Docker container. This is just on my computer, but we're going to try and make a request against that. So let's see if I can get the syntax right. We're going to say curl. We're going to pass some data through with this request. So, and I think it will be JSON. So let's try legs, 8 legs. We could pass some extra things too. I don't think they get picked up, but let's do it anyway. 20 eyes, 8 legs. What could it be? We should specify that we're passing through JSON. So let's say content type application JSON. Okay, and the path that we want to send this to is HTTP. So not especially secure. This is more just for this demo. Oh, and we want to go to the predict path, because if you remember, that was the function that we'd routed this against in our app. Up here. If we didn't hit this path, it wouldn't be making that request. Okay, so let's pray to the demo gods. Okay, cool. That's good. So again, this isn't a mind-blowing prediction. It's not using a machine learning model. But say you did have something where latency was really important. You wanted incredibly fast predictions about your information that you had, your input. You can see how you can use web server software like Flask or something like Gunicorn, don't know how to pronounce that, to stand up your model behind a web server and make predictions against it for these sorts of scenarios. But again, this is still just running on my computer. So what if we want to deploy things to a cloud service? And Docker can help us with that as well. So I'm going to talk mostly about AWS. AWS has ECR, which is the EC2 container registry. And similarly, again, to how you can have like a remote Git repo, this is like a remote image repository. In fact, I'll just show you. So you can push your Docker images to this remote repo. So let's see, I think I put one of the demo ones in here. Hopefully this is big enough for everyone. So we can see, okay, so I pushed the basic Flask demo here. The process of doing this isn't super complicated. You establish a connection using your AWS credentials, establish a connection between AWS and the Docker engine, and then you push this, like, Docker push, I guess, and you end up with your image stored in this repository. So why is that useful? It means then that if you want to take the software that's encapsulated in this image and run it on something like EC2, this is now a case really of just doing a few clicks. And so I won't set up a cluster, but we can see how this might happen. So let's go to ECS, which is the, oh goodness me, it's the EC2 container service. We're going to say we want to create a cluster. We get the choice between setting up one with Fargate or one that's going to be running on a regular EC2 cluster. The difference here is that Fargate is a bit more, it's kind of more like Lambda, but for images, if your image doesn't need to have any state that persists or any kind of data store that persists and can just be run with no context, then Fargate makes a lot of the configurations for running them easier. If you're running it on a kind of traditional EC2 cluster, there's still quite a little bit of stuff that you'll have to configure and fiddle with. But this is the principle. You know, you'd set this and we'd point it, I would give it a name, eco name, and I have to click some more stuff, but at some point, we would then pair this with the image that we have in ECR and be able to run that on the cloud. So it could be, you know, a streaming application like the Kafka one. It could be an endpoint, a web server endpoint. And that's there for us. But like I say, there's still a little bit of configuration here. So say you want to use that to make predictions against like an endpoint. You'll still have to think a little bit about the networking, for instance, or the scaling. And so another option for this is SageMaker. So SageMaker is another AWS service. It's one of their kind of machine learning suite. It's built to be a platform where you could carry out like all aspects of data science work, really. So anything from like labeling your data. So you would store your data here, you could label it, you could train a model on it, either one that they provide or a custom one. You know, they really kind of want to cover this whole life cycle here. But when you get to the point of deploying a model that you've built with SageMaker, all it's doing kind of under the hood is using an ECR image, you know, or a Docker image. And so you could go through all of this, but equally, say you wanted to deploy your model, but it's one you've built already, you've got an ECR image for it. You can kind of skip all of this and use SageMaker to deploy your ECR image. It might have to meet a few requirements, like it might need to have a function with a particular name maybe, or the Dockerfile I think might need to create a directory for some logs to go into, but it's only, you know, a couple of small hoops to jump through and you can use your kind of custom image to run on SageMaker. So why would you do that over ECS? It's really those details that I mentioned. So SageMaker will take care of things like the scaling and the load balancing against that cluster. You'll get things like the output monitoring and CloudWatch. It will take care of the web server side of it as well, like the endpoint. But obviously, it will cost you more money. And so Azure and Google Cloud have parallels for all of this as well. It's not just AWS. So for instance, Azure has Azure container images and the Azure container repository and Azure container services and so on, and Azure ML where you can run these. So I think one thing as well I'll mention is that possibly by this point people are thinking like Docker, okay, it's good and it's clearly good for software. It's a great tool for software that we've kind of stolen, but maybe it doesn't work so well for pipelines. You know, we don't always have neat programs that can run with one command. We can often have messy multi-stage processes, something that's better modeled with a DAG system like Airflow. So how do they merge together? And this is just one last thing I'll talk about because I found out about it recently and I thought it was interesting, which was something called Apache Liminal, which I think looks like it's a kind of hybrid between those two. So you'll see if we look at it, it looks kind of similar to the Docker Compose file we saw. We're setting out different tasks that are going to be built from images. But what it's doing is kind of turning the pipeline that you specify into a DAG that's going to run on a cluster of containers, which is super interesting. I know this is also still kind of early days and they're looking for contributors. So if anyone wants to add to that, that's there. But I think what will be likely is that we won't always have to use Docker images for this. There's going to be more developments on top of images that kind of make it more compatible with traditional machine learning workflows, which is quite exciting. Okay, so quite to the end. So why, what are the benefits of doing this? Why do we want to use containerization in data science? So as we've seen, we get easier development and deployment of quite complex systems. If we've got things which, you know, aren't completely enclosed, maybe they need to interact with some adjacent services. containers can often help us in the development of those. Easier collaboration. So hopefully I've showed you how you could easily share and move these images around and perform better collaboration with other people in the team and other teams. And also the fine control over the environment that you're running code in is appealing, and something that I think is a problem that data scientists often run into. And to some extent, these are already solved with Python environment managers. There are some things that Docker can add on top of that, really. And so when should you be thinking about Docker? It's not necessarily right for every scenario. Sometimes it would be a bit of a sledgehammer on a nut. But say you're working and you know that the environment you're developing in is significantly different from the environment that you're actually deploying your work into. This is a scenario where Docker might save you some headaches by being able to recreate that locally. Alternatively, maybe you've got models that you want to start getting on the cloud. Docker can help us with that. And yeah, finally, if maybe you want to start sharing your work, or maybe you want to get involved with open source projects, I think you'll find that Docker is often used as a way to ease that sort of collaboration. Okay, so that's it. I think questions are being collected somehow. I've put some links here. So the demos that I showed are all in GitHub, and you can pull that repo and run them, and you should see the same things that I did. The Docker docs are really good. They're really, really nice. I'd recommend having a look through. This link, admittedly, I haven't tried, but I came across it when I was doing some research for this talk, and it seems like a cloud environment where you can practice using Docker, practice the basics of Docker, but without having to install Docker, which is quite cool. And yeah, finally, if you have any comments or anything, please get in touch. Thank you.
Well, thank you very much, Rebecca. That's fascinating. Really good breakdown of a complex topic.
Thank you.
So we've got a couple of questions now. So the highest voted question, which isn't a question. Thank you very much for a really good talk with a nice balance of slides and demos.
Oh, thank you.
That's nice, very wholesome. And yeah, it's a very good talk. Will you be sharing the slides afterwards?
I will add them into that repo. Yeah, I'll add them into that repo.
Cool. And we can circulate around for anyone who wants to peruse them later on. So we got a question from Alex. So how do you handle security vulnerabilities introduced by third-party images?
Oh, that's a good question. I mean, I think I would kind of trust the fact that they are so widely consumed and mostly open, that that would surface any problems. I don't know specifically of like a local strategy you could use to protect against those, although I'm sure there are some. I would say, I mean, if you find that you want to use images that you can't necessarily vouch for, maybe you could get in touch with the people. There's not a scenario I've come across, I'm afraid.
Yeah, no, I think that's fair. I mean, in my own experience, certainly with kind of like the official Python images, big that are supported by open source software, I definitely take the same approach as you. Open source software is generally very trusting. However, I will say when I've worked with other large corporate organizations that aren't quite so trusting, they've in kind of like an automated CI/CD pipelines, sometimes they have a step to kind of do automated scanning, which there are tools and software you can do. I have absolutely no idea how it works.
That's an option in ECR actually, in the container repository. I think it will scan images for you, so I'm imagining it will do something similar.
Yeah, I mean that seems massively overkill for doing local work, but certainly if you are working in a secure environment or heavily regulated, I can imagine how that would be a factor.
Yeah.
Or working for a large corporate production environment.
No, definitely. Thanks for that question.
Thanks, Alex. And Carl, I'm sorry, Carlos, I apologize. He asked a similar question about do you use anything to get security notifications? Which I'm not sure is pertinent if you don't do the automated scanning.
Yeah, I don't, I'm afraid, but I'm sure there's stuff out there that you could use.
So a question from Anonymous. What kind of monitoring and logging do you have for production containers?
So you can use, so do you mean like for the actual running of the containers? Say you're using AWS and you've got that container running on EC2, you'll be able to use the things like the CloudWatch monitoring in AWS to look at those, to look at that cluster. Also within services like ECR, you'll get a view on the activities of those tasks. They're called tasks once they're kind of running on a cluster in that way. And so kind of using the standard like monitoring and alerting in AWS, you can kind of join that all up.
Okay, cool. I mean, that makes sense. So in terms of kind of your day-to-day work, is there like a standard set of Python images that you use? Oh, sorry, not just Python, but whatever tool.
Yeah.
Is there a set? Sorry.
Oh, sorry, I didn't realize that was a question.
Yeah.
I think typically I would work from the Python image, Ubuntu sometimes. I think perhaps the Postgres SQL one adds in some useful functionality, but I find personally there isn't a huge range that I interact with commonly. The Python one is usually enough for whatever I'm building on top of it. Yeah.
Oh, that makes sense. For Python tasks.
Yeah, because once you've passed in, so if because you're still passing in things like the requirements.txt to pull your packages. So it's really if there's any software on top of that you'll use. So it'll most likely be, so something like Postgres to add the database functionality that you could still include just from the Python base image, but it would save you a bit of work.
So on a more difficult note, I mean, are there what's the biggest problem you've found when using Docker containers? The biggest headache?
I mean, one of the things is almost just the learning curve of starting to use Docker, which hopefully this has eased a little bit.
Yeah, definitely.
Otherwise, I think probably it's how do you make it kind of compatible with pipelines, like I mentioned towards the end. So trying to figure out the details of running more like interdependent tasks within containers is probably a bit tricky. But I think that's where, things like liminal and kind of almost like wrappers on top of containers are going to be helpful as people realize that actually data scientists want to use this stuff as well. So yeah.
Yeah, definitely. I would definitely echo the issues with orchestrating multiple containers for pipelines. Definitely a pain. Cool. So a question from Michael who just pops a question in. When do you think it's worth using container orchestration such as Kubernetes above using just Docker?
Okay. So as I understand it, so Kubernetes, for people that don't know, is if you want to be running Docker across a cluster of machines such that the containers are also distributed across. So I would say, I mean, if you're not just using Docker for local development, but you are, deploying Docker images and you are deploying onto a cluster like an EC2 cluster, I think you can get much finer control over the operation of those containers on that cluster if you use something like Kubernetes. So I think so I guess my answer would be if you are running stuff on the cloud like this or on a cluster, but you find that you want more control over the way that Docker is executing the tasks against that cluster, I think Kubernetes can be used so it will automatically distribute and scale the input to the different tasks and containers across that cluster, maybe in a smarter way than you'd get just with Docker. But I think there's also Docker Swarm, so maybe that was mentioned in the question, so like another sort of functionality of Docker that is kind of aiming to do that same thing as well. So orchestrating the distributed containers more precisely. Thanks.
Well, that's a good answer. Thank you. James, sorry, just noticed a James question. Yeah, just about running Spark locally and the difficulties of
Yeah,
operating it with local mode and working mode, which I frankly don't understand enough
we
about.
empathize. We empathize with you, James.
I'm glad I don't have to do that. It sounds very complicated. But I believe that's all the questions we've got at the moment.
Okay, great. I put up my contact details, so feel free to send me stuff that way as well.
Yeah, thank you very much. Thank you very much for joining us. And we're going to be trying something new this evening. So, as we can't all go to the pub and have a nice chat and a beer, we're going to be going to Gathertown. So, if you've got any more questions for Rebecca, if you want to chat about any of the other audience members about the talk, about data science, about life in general, Joe will be putting the link to Gathertown in Slack. So yeah, please get involved, and I think he'll be putting it in YouTube as well. The link will be available, so you can join in, have a conversation with us, and get involved. Hopefully, we'll see you soon. Thank you very much for joining us today, Rebecca, and for the fantastic talk.
Thank you. I'll see you in Gathertown.
You can get it now. Bye, everyone.
Bye.